Hello everyone. Hi, very nice to be here, to be back in China. It has been 7 years for me, and I can see a completely different country. It's crazy, yeah? The speed of evolvement of China, it's truly impressive. And I already learned a lot today to see all the beautiful digital developments that are happening also in the water space. So yeah, thank you for the organizers. Thank you IWA for having me here. It's a true honor. That's great. The Chinese translation is really working well. I hope it's good. It's working. Okay. So I'm from Belgium in Europe, and today I'm going to give you a little bit of view on what are we working on in Europe and the US, for example, when it comes to digital water. So that's always interesting because we are having many similar challenges and opportunities, but also some things are specific. So with this talk, I want to give that overview a little bit. Okay, so I'm CEO and co-founder at AM Team. We are a Belgian company that provides modeling services and digital twin solutions worldwide for utilities and companies in the water industry. So I will start with the hype and the needs, or the hype. Yeah, it's more than a hype, of course. The big opportunities, some examples of applications from the US and Europe, and also some take-home messages, okay? All right, is it a hype or is it a trend? I think we all agree that it's more than a hype. It is really a trend. However, there is some hype. I will explain that a little bit. I don't know if you have seen this figure before. This is the landscape of human competence. So it was published in the 90s, so 1998, okay? It was published in a scientific journal. And this publication by Hans Moravec was doing a prediction on how will AI replace humans. So the mountains here on this figure is what what humans can do. The rising water is what computers can do better than humans. And of course, we already know that, you can see that chess flooded. Yes, we already know that from the 1990s. But in the meantime, we also know that computers can also beat us in Go, right? So that happened in 2015. And interesting to see that, for example, book writing, art, programming, were considered relatively high mountains in the 90s. But I think we all agree that we might have to revisit this figure a little bit because AI is moving very fast. So I asked AI, can you just create me a more beautiful image of this landscape? And this is what it did. Now, there is a little bit of things missing here, I think. So the static mountains are human skills that are going to be flooded. However, we miss some dynamics. Right? We miss, I think, an iceberg. For example, if the water goes up, some jobs will disappear, some things will be completely taken over by AI, but of course, some human competences will be driven up as well significantly. Of course, we will have a major empowerment. Of course, if you now start a business, or you manage your company, or you are in a certain job, it is of course smart to think, what is my iceberg? And it is probably good to develop a vision to escape that static mountain. That's for sure something that we must look into. So since this 2015, a lot happened, when this computer beat somebody with Go, This is the use of the phrase digital twin as function of time. You can do the same for AI, a lot of things. This is more than an exponential, right? It's like a vertical curve. So, the pivotal moment was really when this happened, and of course you are very familiar with that game. We don't play it in Europe too often, but that was really a very crazy moment in time. And since the last 10 years, a lot has changed, of course. This has driven a lot. The key question I always ask myself is, how will this then translate to adoption in the water industry? Because in the end, we can go for AI, we can try to implement AI or models or digitalization, but it has to bring value. And what is that value? Well, to look at the value, it's always good to start with some challenges you can potentially solve. For example, this is the water system, and these are some typical challenges we have in Europe and the US, for example. They are very similar, I believe, in China. We are talking about climate change mitigation and adaptation, very big, you know, having models that can mitigate greenhouse gas emissions, for example, having models that can help running future scenarios 20, 30 years for planning, future-proof system design. We need to shift drinking water sources due to droughts. Also in Belgium, for example, Belgium is a very rainy country. We have droughts since 10 years, a lot of droughts. Right? That's one example. Water use, chemical pollution, more stringent regulation, etc., etc. So these are challenges digital can potentially help solving. Now, what is the business case? A business case is always combining a problem with a solution. So these are the challenges or the problems. I just listed them on the figure. And let's look at the emerging technology, of course. Yeah, of course, we have artificial intelligence coming. We have computing power. We have cloud computing. You know, you name it. All these things that were not there 20 years ago are now here today. And this creates, of course, a great opportunity. When we look at the business case for digital water, I think they can be found in these 5 domains. And we have seen them throughout the presentations already. For example, Professor Zigo Yuan also mentioned them, right? It's not only operations. It's not only a smart plant. It's also about planning, short-term, long-term planning. But it's also about training people. Because, for example, in the US, in Europe, we have a huge skill bottleneck. You cannot find technologists anymore or operators. Maybe they will also be replaced, but that's another discussion. But the thing is, we can really accelerate the learning with digital tools. So I will now go to some concrete examples, some use cases. It's a very short time, 25 minutes is not a lot. I have just picked 3 examples, and I will focus on the treatment side. What I mean with this, a very mature application, of course, of AI throughout the last 10 years already in Europe, US, is asset management, of course, network leak detection. These are very mature areas. You have even a lot of companies working on that. Over 100 companies, I would say, on leak detection, for example. They keep coming. On the other hand, the treatment side, that is my focus here, because I believe there is still a lot of work to do here, and mainly because the data quantity and the quality are low. And if we don't have this, we have some model challenges. So, first example from the Netherlands, where we are talking about an advanced treatment digital twin. So we used actually models throughout various stages. They were building a new treatment plant to remove micropollutants, for example, pharmaceuticals from the wastewater. The plant was not been built, so it had be first planned, then it went to the design stage, and then it went to the construction stage and the operational stage. So we started building a digital twin, of course, early in the process. And this is what we call virtual piloting. In the virtual piloting stage, computer models completely replaced real pilots. And then we recycled those models to the design stage, where these same models were used to properly design the plant. And finally, when the plant was built, we recycled the models again as a digital twin. Now, this is not common practice, because how the water industry is configured, typically design people are very different from planning people. You hand it to an engineering company, they use a model, the model is never being looked at anymore when the design is finished. Then the operations team is completely different. But when we look at digitalization, a big paradigm shift is recycling those models throughout those stages. This is a lot of value. So this is a big change that's coming. In the end, the reactor looked like this, not the colors. The colors are the simulation outcomes. Maybe we should paint the reactor like this. That would be beautiful. But for example, this computer model shows you in 3D byproduct formation, the removal of chemicals, you know. This is an advanced digital twin. So we literally have these visualizations in 3D in real time. We do the same for greenhouse gas emissions. You know, this is just one example. The beauty of course, digital twins is that you can use them as soft sensors. This means you can predict what cannot be measured based on what can be measured. For example, every line here is an individual pharmaceutical and how it's being removed. You cannot measure this with real sensors, but you can predict it with models. And you can see also that these models can do quite a good job. There's quite a good alignment with the model and the data. So this is a very good application of soft sensoring about variables you cannot really measure. So this is a summary of that case. In the planning stage, they wanted to choose a technology. In the design stage, they needed to design the technology to meet the requirements. And in the operational stage, they needed to train operators and also have a real-time control. So this means, for example, in the planning stage, in this case, the utility on this plant only saved around €500,000. I think it's a factor 10 in yen, you're right, it's a factor 10 we have to do, so that's 5 million. 90% savings, they also saved 1.5 years of time. Then we also, with the models, we could reduce with 40% the byproducts. We could meet the effluent goals, and now the plant is in operation, and we have a real-time soft sensor. And the operations team was already trained, of course, using the digital twin, even before the real plant was being built. That's a very good business case, of course. I'm focusing here on the business case. Second one, let's go to the US, wastewater treatment digital twin. HRSD is one of the most innovative utilities in the US, so they are quite well known for technological innovation. They're in Virginia, in the state of Virginia, and they work together on, we actually also work with them on SWIFT. SWIFT is their biggest reuse project. So they are turning wastewater into drinking water. And I will give some history lesson here. This is a paper from 1986. That was the year I was born. So I was born exactly at the same moment of this paper. This is quite advanced. This is 40 years ago, 40 years ago, okay? These people already constructed the first concept of a digital twin. I think this is the first ever published concept of a treatment plant digital twin. I have not found, or we did not find, earlier references. What you're talking about, okay, this is a simulation, the virtual plant, you have the real plant, you have a person looking at the screen, you have some models, and you also have, I'm going to check here, this is actually a data-driven model. Today we would call it AI. Right? This is an AI component, this is a mechanistic model, and you have automatic calibration of parameters. 40 years ago, quite advanced. Now, the pity is, in the water industry, it took us 40 years to go to the real application, 4 decades. Luckily, these same people are still alive, and they are still active, in fact, you know? We are actually working with them, and today, this thing is reality, of course. So this is the digital twin at one of the facilities of HRSD, automatic data processing. Because at wastewater treatment plants, we have seen it in the previous presentation, data is poor, very bad quality. Having sensors is a disaster, right? So you need very good data cleaning. You feed it to the digital twin, you auto-calibrate. The model predicts you certain things you cannot measure. And then, of course, the beauty is you can automatically control your plant. So this is a fully closed loop system. So the model is closed loop. This means you have a direct control of the plant. And the system is already in operation for 1 year now, okay? 1 year operation. The reason I'm zooming in on this digital twin, because I have seen, of course, in China, you have a lot of digital twins already. But I think the specifics here is that this model is a full mechanistic hybrid, let's say, wastewater treatment model. And in the end, the results are nice because they want to have a more stable ammonia in the effluent. This is before the digital twin. And finally, you implement the digital twin and you see ammonia fluctuates way less. And further refinement, of course, led to an even better performance. And that's what you can see here. So they're almost on the 1.5 milligrams per liter regulation continuously. In wastewater, everybody that knows something about wastewater treatment knows this is quite a challenge. Huge cost saving as well in aeration. Yeah, it's a huge aeration cost saving. That's what you can see here. Operating at way lower dissolved oxygen. Okay, I'm now going to drinking water treatments. Like I said, in Europe, we are facing major climate stress, and we have a drinking water company in the region of Amsterdam in the Netherlands. And they are building a climate buffer. This means their drinking water source needs to be buffered because the salinity is increasing due to prolonged droughts caused by climate change. So again, same principle. We started using models already 7-8 years ago to design these wetlands, you see, these buffer systems. And now we are going to bring it alive. They are being built and bring it alive as an integrated digital twin. So the digital twin will predict the whole system, of course, the whole source, the whole area, and the whole treatment plant in detail. It will also be coupled, of course, with energy. For example, this is just one example, CO2 footprint as function of time, because there are solar panels, and they're also controlling the process as function of solar energy production, etc., etc. So this is multi-criteria digital twins, let's say. Yeah? They do not only look at water quality, but they also look at energy. Good, this brings us to the conclusions. When you look at the digital twin, a twin is two, right? You have two babies. And a digital twin, often people think, okay, we have an existing facility, and we will build the virtual component of that facility. However, digital twins can be built earlier. So this means the virtual baby, this virtual baby can be built first. And that is the value. You use the virtual baby in the design stage, in the planning, and then you can go to the real plant. Or for existing plants, you go the other way around. So there's a lot of value if you start building a digital twin, of course, in the early stages. And the second is that we often see that models, certainly with the hype of AI, are not being used in the right setting. You have to use a hammer for a nail and the screwdriver for a screw, right? So I think this is better. This is better. So this means when you look at AI, you will apply AI in situations where you have a lot of data of good quality. Treatment plants have not so much data of bad quality often. It's not that AI cannot be used there, but it's smart to look at hybrid approaches, with other models and things like that. And that's what we often see with the hype. People tend to forget these things. So thanks for listening to my talk, and thanks again for the invitation.